So these are our objectives for this video. We're going to go through intervals on a number line. We're going to go through the basic principles of solving inequalities. And we're going to use the different properties that we learned with equations and apply them to inequalities. And then we're going to start solving some problems with inequalities and with multiple steps. So an inequality relates algebraic expressions that use specific symbols. So we have less than, greater than, less than or equal to, and greater than or equal to. So this is kind of what I explain this as. Let's say you have a bill to pay, and your bill is $200 for the week. So you know your paycheck on Friday has to be at least $200. At least would equate to greater than or equal to 200. Anything over that is fine when we say at least. If we get paid $250, it still works. So when we're relating to inequalities, we have to really analyze our language and look at what are we saying and what does that phrase mean in terms of number values. So we find an inequality, we solve them by finding multiple answers. Inequalities don't have one solution. They have many solutions. So for an example, when we have x such that, that's the bar, x such that x is less than or equal to 2, that's an infinite number of values. It could be 1, it could be 0, it could be -1, -2. So inequalities have a range of solutions because of the nature of how they're worded. So when we're graphing intervals on the number line, we're going to talk about some different conventions that are used to do those intervals. When we have something that is equal to, there are two ways to show that on the graph. The first way is, as the slide shows, we show a bracket. A bracket is what is used with equal to. However, as you may see in the knowledge path or in the lab, we could also draw a circle there and color it in. So we would either use a bracket or colored in circle if it was equal to was in the problem. When we're using interval notation, because it is equal to, I use a bracket. So if I'm looking at the same thing here, I have from 2 all the way over here with the arrow forever. And when we read number lines, we read them from left to right. So this over here would be negative infinity. So we're saying negative infinity all the way to the value of 2. And negative infinity just means that that arrow is pointing to the left. If it was pointing to the right, it would be positive infinity. So a square bracket indicates when a number is included or equal to. So if I'm looking for x is greater than or equal to 3, my interval would be from 3 to infinity, because the numbers that are greater than 3 would be 4, 5, 6, 7, 8, 9, 10, so on. On the graph, I would use a bracket or a colored in circle, and I would shade to the right. Now I want you to notice this. Look at the way the inequality points. It points to the right. Look at where I shaded, to the right. So on our number line, this is negative infinity, 0, and positive infinity. And I could use that inequality symbol to help look at which way I would shade. Now if I have -4 is greater than x, it's not greater than or equal to, so I use a parenthesis here. Then on my number line, I would use an open circle or a parenthesis. And this is a little bit tricky. I don't shade in the direction of x. Why? Look at x is over here on the left, and now it's on the right. So the problem with shading in the direction blindly and just saying, oh, I always shade in the direction of the inequality, is that when the x is on the other side, it would swap around. So this is really saying that x is less than -4, so that's why I would be shading in this direction. So a parenthesis is when something is not included. So we'd use a parenthesis or an open circle. A bracket or a colored in circle is when it is included. And we always use a parenthesis by infinity because we could never actually be at infinity. So now let's start looking at some additional properties. So this is going to work just like when we were solving for the linear equation. So if I look at this thing, the first thing I want to do is I want to get all my variables on the same side. So I'm going to subtract 7x from both sides to get it over here on the left. Then I simplify. 8 minus 7 is 1. Now I want to get that x alone. So I have a -1. I'm going to do the opposite of -1 and add 1 to both sides. And that's going to give me x is less than 3. Because that x is on the left-hand side of the inequality symbol, I can use the shortcut to shade in the direction of the arrow. And because it's less than and not less than or equal to, I would use a parenthesis or an open circle. So the principles that are being used here are the same ones we use with equations. Now I want you to consider 3 is less than 7. And that's a true statement. What happens if I multiply both sides by 2? It's still a true statement. But what happens when I multiply by a negative number? It's a false statement. So think about that for a minute. Why did a negative number change the game here? Because when I'm multiplying both sides by a negative number, there is a special step we must do with the inequalities. So in order to keep this inequality true, I have to reverse the direction of the symbol. So I know you've probably read in the reading all about why we have to reverse the symbol, but you don't know why. It's because when we reverse it, that's the only way to keep our statement true, is to reverse the image. So when you multiply or divide by a negative number, you change the sign of the inequality. If it's a positive number, you don't change the sign. So this rule is only going to apply when you're using negatives. So if I have negative 2r is less than negative 12, negative 2r is read as negative 2 times r. So to get r alone, I have to do the opposite and divide both sides by negative 2. That gives me r is less than 6. What happened? Look at that symbol. Because I divided by a negative number, I changed the direction of my symbol. Then on my graph, I don't have an equal to, so I'm going to parenthesis or open circle, and I'm going to shade in the direction of the inequality symbol. Now let's work on solving multi-step inequalities. So when we're solving multi-step inequalities, this is going to be the same as multi-step equations. We want to get rid of any parentheses first, clear out any fractions or decimals, and then combine our like terms. So those are just kind of the additional steps that are going to be necessary there. And we're still going to work on, after we've done those 3 things, then we start talking about getting a variable alone. So if I look at this question, the first thing I see that I can do is I can combine some of those like terms. So 5 minus x would be 4x. Now I'm going to say I don't have my x's on one side, so I want to move my x's to one side. Now I would subtract 4x from both sides because it's easier to have positive values than negative. So when I subtract 7 minus 4, that gives me 3. Now I want to get that 3x alone. So I'm going to add 5 to both sides. I'm going to simplify that. And 3x is 3 times x, which I would divide both sides by 3. And then this is just a really awkward solution. So chances are you would probably write this in your assignments as x is greater than 7/3. You probably wouldn't leave it like this. So I'm going to go to 7/3. It doesn't have to be the exact value. And then I would shade in the direction of the right. Because the x is on the right-hand side, you're shading in the opposite direction. Now this is another multi-step problem. So we have a distributive property in play here with this parentheses and with this subtraction symbol. So I'm going to do 4 times x minus 4 times 1. I'm going to do negative 1 times 2x is negative 2x. Negative 1 times 1 is negative 1. Once I get that, I'm going to simplify. 4x minus 3x is just x. Negative 15 minus 1 is negative 16. Then I'm going to try and move those x's around. I would subtract x from both sides or add 2x. It really could go either way here. But I like having things on the left. That's my personal preference. So then I'm going to combine those terms. I want to get 3x alone, so I will add 4 to both sides. Simplify. Then I'm going to divide both sides by 3. So when I move that x to the left, now it's easier to shade my inequality graph. I'm going to put my parentheses or my open circle at negative 4. and I'm going to shade to the right. Here's another example, multi-step. We have distributive properties here, and this is going to be not the prettiest equation because I'm going to have to do 1/2 times 3 minus 1 times 1/2. Then I'm going to do 1/5 times x and 4 times 1/5. If I multiply both sides by 10, that will clear out my fractions because the least common multiple of 2 and 5 is going to be 10. So here this would cancel and be 2 would cancel with 10, and I would get 5 times 3, which is 15. The 2 would cancel with the 10, and I would have 5 times 1. Once I get that settled, I want to solve and get all the x's to the left, so I would subtract 2x from both sides. 15 minus 2 is 13. Then I'm going to add 5 to both sides. Then last, I will divide by 13. And notice my sign didn't change because I didn't multiply or divide by a negative number. I'm going to put my open circle at 1 and shade in the direction of the inequality. So this is kind of what I put together as a vocabulary slide because sometimes it's hard to know what the vocabulary means in terms of an inequality. So if I want something that's more than 4, that would be greater than. A number that is less than -12, that would be less than. If I want it to exceed something, that's a greater than. At least is a greater than or equal to. And at most would be less than or equal to. So those are just some common phrases that I think we kind of think or say every day that'll help you clarify what you're supposed to be using there. So Maggie has test scores of 98, 86, and 88 on her first 3 tests in algebra. She wants to have an overall average of a 90 after her 4th test. What score must she make on the test? So we're going to consider that X is going to be her score that she makes. We're going to average them. So just like you average your grades, you add up all the points possible and you divide by the number of tests. So we divided by 4. If she wants at least 90, that's greater than or equal to. So we're going to go ahead and complete the addition here. And then I need to get rid of the 4. So I'm going to multiply both sides by 4. Then I'm going to subtract 272 from both sides. So she has to be greater than or equal to 88. This is kind of an advanced question that you would see with inequalities, but it's a very common one because we're all very familiar with finding our average in a class. I know sometimes we depend on a grade book, but most of the time you guys are really great about playing with your grade and figuring out what you would have if you scored X on a test. So now we're going to look at solving linear inequalities with 3 parts. So this would be an inequality where I have values on the left, the right, and in the middle. So this would be saying that X is greater than 2, but less than 4. So what does that mean, greater than 2, but less than 4? That means 2 is not included, because there's no equal to, and then it goes to 4. So that's my interval. This reads as between 2 and 4, with 4 included. Then if I shade it, it's going to be shaded as an interval. Notice it doesn't go on forever in either direction, because I'm given a specific interval here. Now, how does this work? Oh my goodness, there's 3 sides and there's equations. You treat the 3 sides just like you would a regular equation. I want to get 3x alone. So I'm going to add 1 to all 3 sides. I want to get that x alone, so I'm going to divide by 3 to all 3 sides. Now I know my answer is between 1 and 3. I use brackets because they're equal to, and I would shade between 1 and 3 on the inequality. So really there's nothing new here, guys. It's just 3 sides, so you're doing it to 3 sides instead of to 2 sides.